This video is another example of how to use a comparison test to determine if series converges or diverges. So in this video, we're going to solve two problems. This is number 2a. Determine if the series summation n equals 1 to infinity of arctan of n divided by n squared converges or diverges. And then problem 2b, determine if the series summation from 1 to infinity arctan of n over square root of n converges or diverges. So before we solve these two problems, let's recall the comparison test. It comes in two parts. So let's write it here. Also called the direct comparison test or nth term comparison test. Suppose series a sub n equals 1 to infinity a sub n and n equals 1 to infinity b sub n are two series with all positive terms. So it's important to realize that the terms are positive. A sub n is positive for all n, and b sub n is positive for all n. Here's the first part of the comparison test. If the b sub n series, n equals 1 to infinity b sub n, converges and then a sub n is less than or equal to b sub n for all n, then n equals 1 to infinity of a sub n will also converge. And here's part 2. If the b sub n series 1 to infinity b sub n diverges and a sub n is greater than b sub n for all n, then the a sub n series also diverges. So those are the only way you can use the comparison test correctly. So let's review the graph of arctan of x. So arctan of x also is tangent inverse 10 to the minus 1 power of x, or 10 to the minus 1 of x. Here's the graph. Here's what it looks like. It has two horizontal asymptotes. On the right, it's pi over 2. On the left, it's negative pi over 2. And here's what the graph looks like. This is from x from minus infinity to infinity. We're not interested on the left. We are only interested in this graph starting at 1. Arctan of 1 is pi over 4. So from that, we can conclude that arctan of n is smaller than pi over 2 and greater than or equal to pi over 4 for all n greater than or equal to 1. That's usually how our sequences start, with 1. So remember, this inequality has two sides, the left side and the right side. So now we can answer question 2a. Question 2a says we have a series from 1 to infinity of arctan of n over n squared. So we know that arctan of n is less than pi over 2 from the graph. If we divide both sides by n squared, we have this inequality. Arctan of n over n squared is less than pi over 2 over n squared. So we're going to call arctan of n over n squared our a sub n sequence, and we're going to call pi over 2 over n squared our b sub n sequence. And now the series from 1 to infinity, 1 over n squared, we know that this series converges. And the reason why it converges, you can cite a couple of reasons. It is a p series with p equals to 2, which is greater than 1. And that means it converges. Or you can just verify it directly by using, for example, the integral test. And that should be enough. You can just say it here. And if this series converges, then multiplying it by pi over 2 is not going to make it diverge. It'll still converge if we multiply it by pi over 2. So the b sub n series, which is 1 to infinity pi over 2 over n squared, converges because 1 over n squared converges. And since b sub n is greater than a sub n, term by term, we can conclude that the series n equals 1 to infinity arctan of n over n squared, which is the a sub n series, also converges. And the reason we can say is by comparison test, or the direct comparison test, whatever you can call it, you want to call it. So I'll just call it the comparison test. And this is the appropriate way to use it. And now let's look at number 2b. For number 2b, we're going to use the other inequality for arctan. Remember, arctan is greater than or equal to pi over 4, less than pi over 2. This time we want to use the one on the left, that it's greater than or equal to pi over 4. And that's what we're going to start it with. Pi over 4 is less than or equal to arctan of n. We're going to divide both of these terms, constants, by square root of n. Pi over 4 over square root of n less than or equal to arctan of n over square root of n. And again, we're going to call pi over 4 over square root of n our b sub n sequence. So b sub n is going to be pi over 4 over square root of n. And a sub n sequence is going to be arctan of n over square root of n. And so let's look at the series from 1 to infinity, 1 over square root of n. That's the same as summation from 1 to infinity, 1 over n to the 1/2 power. This series diverges, and you need to state a p series with p equals 1/2, which is less than or equal to 1. It's between 0 and 1, and for that range of p, the p series diverges, or you can use the integral test to confirm that this series diverges. And so because it diverges, if we multiply it by pi over 4, that's not going to change that it diverges. The pi over 4 over n to the 1/2 is also a divergent series. Summation 1 equals n equals 1 to infinity pi over 4 over square root of it also diverges. Now the a sub n series, since a sub n is greater than or equal to b sub n for all n, we conclude that the a sub n series, arctan of n over square root of n, also diverges by comparison test.